guys, this video is going to be covering chapter 8. It's the final chapter of the semester, and the sections that we're going to be doing are actually both 8.1 and 8.2 because they're both pretty short, so I don't want to have to worry about breaking it up into more than one video. So we're going to go ahead and be starting on page 519, and this is 8.1. All right, the objectives of 8.1 is to find square roots, find cube roots, find the nth roots, approximate square roots, and simplify radicals containing variables. For example 1, some background information. The root of a number is the opposite of raising a number to a power. The square root symbol or radical is expressed by, you can see this in the PowerPoint symbol, it looks kind of like a check mark with a line at the top, in which the square root of a squared equals a, and the square root of, or the negative square root of a squared is negative a. And we are going to, as we get more into this lesson, you're going to see that where the negative sign is outside the square root or inside the square root does make a difference. Okay, so we're going to go through 5 examples here. Well, all under example 1, of course. And we're going to go through and solve. So we have the square root of 100, and I'm just going to write all these out and then we'll go through together. All right, on the first one, actually I should say on all of these, if there's no number written in this, the root symbol, then that just means it's a square root of 2. So what times what? And it has to be the same number twice. What times what equals this number? So what times what equals 10? The answer of that would be, equals 10, equals 100. The answer of that would be 10. 10 times 10 is 100. So if I take the square root of that, it's 10. And as long as it equals out an even number, you can actually do this in your calculator as well. Okay, notice the negative sign is outside of the symbol. So what this means is the opposite of the square root of 136. So what we're gonna end up doing, obviously a negative number, if it had a negative on the inside, anything I multiply times itself can never equal a negative number twice. So if I had, like here, if I had 10, negative 10 times negative 10, it'd still be a positive 100. If I had negative 10 times positive 10, then that's not the same number being multiplied by itself. So we can't actually have the negative sign under the radical. So this negative sign is just saying whatever you get is your answer, it's the negative of that. So 136, the square root of 136, wait, is it 136? Oh, I wrote that wrong, I apologize. That actually should be just the square root, the negative square root of 36. I was about to say, I don't think that comes out evenly. So 36, we can take the square root of. The square root of 36 is 6 times 6. So that would mean the square root of just 36 is 6. What's the opposite of 6? Negative 6. All right, with fractions, this is the same as we've always done. You treat the bottom and the top separately. So if I take the square root of 25, what times what equals 25? That would be 5. And on the bottom, what times what equals 81? That would be 9. Okay, 1. What times what equals 1? 1. 1 times anything equals 1. Well, 1 times itself, any amount of times equals 1. All right, 0.09. So what times what equals 0.09? Now that one you might end up having to do in your calculator, which is totally fine. The answer to this, if you were to just take like the square root of regular 9, it would be 3. In this case, it's gonna be 0.3. All right. So I went ahead and actually, you know what, before I erase this, I'm gonna let you do your practice problems first. So you're gonna do A, B, and C on your own. So go ahead and try it on your own and then check your work. And we are on page 520 for the practice problems. All right, so for A, you got to take them separately. Square root of 4 is 2. Square root of 81 is 9. For this one, we take the square root of 25, which is 5, but it's the opposite of that, so negative 5. This one, square root of 144 is 12. 12 times 12 is 144. Example 2, a cube root is expressed by the radical of when you have the radical sign with a little 3. So you can see where it says 3 radical 125. So what that means is what number times itself 3 times equals that number under the radical. This would be a number that has been raised to the 3rd power. So if I had like 5 raised to the 3rd power, 5 times 5 times 5, that equals 125. So if I take the cubic root of 125, it would be 5. All right, let's look at our examples. All right, on our first one, so actually we already did this, but the cubic root of 125, what times what times what? 5 raised to the 3rd power would equal 125. So the cubic root of 125 would be 5. All right, now notice we have a negative sign under the radical this time. Negative numbers can only work with odd radicals. If it's even, it can't happen, okay? So negative numbers, it would be no solution if there's a negative sign under an even number radical, but this is odd. So it is possible. So what we have to ask ourselves is the same exact number times itself 3 times to equal this number. So I know automatically with 8, if I multiply 2 times 2 times 2, I'll get 8. But I'm not getting positive 8, I'm getting a negative 8. So how can I get negative 8 instead of positive 8? Well, if I do negative 2 times negative 2 times negative 2, because it's an odd number of negatives being multiplied, I'm going to end up with an odd number. If it had been even, then it'd be a positive. But odd numbers being multiplied by itself become negative. Okay? On the last one, the cubic root of 1 is 1. 1 times 1 times 1 is 1. 64, what times what times what equals 64? And that would be positive 4. All right, go ahead and try your own. You're going to do examples A, B, and C again. This is example 2 on page 521. All right, on the first one, 0 times 0 times 0 equals 3. On this one, 64, the cubic root is 4, but it's negative 64. So negative 4 times negative 4 times negative 4 equals negative 64. Cubic root of 1/8, the cubic root of 1 is 1. Then on the bottom, my denominator, the cubic root of 8 is 2. So the overall answer is 1/2. All right, finding the nth root of a number applies to numbers raised to the power other than 2 or 3. Only odd numbers can contain a negative sign under the radical. Even numbers with a negative sign under the radical are not real. So for example, if I had the fourth root of negative 81, that's not a real number, because I can't have a number multiplied 4 times and become negative. It's not possible. So that's not real if you have a negative under an even root. If it's odd though, then it's okay. So it's just one of those rules you have to remember. All right, so let's look at our examples. All right, so on the first one, what times what times what times what? We're multiplying the same number 4 times equals negative 16. Well, I hope you didn't say negative 2, because that's not right. This is even, and we have a negative number under the square root, or not square root, but under the radical. So this, not real. Okay? Letter B. We do have a negative number under the radical, but it's odd, so that's possible. So what is the root of 1 times itself 5 times? So anything of 1 is 1, but this is negative 1. So because this is an odd number, that means it's going to be negative 1. Negative 1 times itself 5 times equals negative 1. All right, here we have 256, and we're taking the fourth root of it. So if you're not really sure where to start with 256, honestly, you could start breaking it down into factors. This is, well, one place to start, I guess, here. I mean, we know it's divisible by 2. This isn't necessarily going to give us, get us to the exact answer just yet, but it is going to lead us there. So 256 divided by 2 is 120. See. Hold on, I don't want to. Okay, 128. And then 128 is 2 times 64. And then 2 times 32. Okay, so what I'm doing here is I'm building my factors to see. This is one way of doing it. I mean, I guess I can just keep going. Whoops. Okay. So what I have now is a bunch of 2s. So what I'm going to do is count this up. I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 2s. So if I were to actually combine 2 of those 2s together, two times 2 is 4. So 4 times 4 times 4 times 4 equals 256. So what is the fourth root of 256? 4. Now, if you want a simpler way of doing this, this only works if it comes out evenly, but you can put it in your calculator. There is a button on your calculator. Not everybody's calculator is different, but there's one that has this symbol on it. Oops, that was an awful drawing. Hold on, let me try it again. Okay, so it has an X right there. So you would want to use the button that has the X there, so that way you can put which number, what root you're trying to take of the original number. All right, so I'm going to erase some of this mess, and then I'm going to let you go ahead and try A, C, and D on your own. But I did all this to show you there's a method to do it without your calculator. Well, without the button that takes you straight to the answer. Just in case you end up having problems trying to figure out that button. Okay. All right, on the first one, 3 times 3 times 3 times 3. So multiplied 4 times is 81. Before I tried to find this answer, I noticed, wait a second, that's an even root. That's a negative number. Can't happen, so not real. Negative 125, take the cubic root of that. So what times what times what equals negative 125? Negative 5 times negative 5 times negative 5 equals negative 125. All right, example 4. Some numbers cannot be completed with prime numbers. In this case, use the function on your calculator to solve the decimal of the radical expression. So on this one, if you go to your calculator, press the number under the root symbol. So I'm going to press 8, and then on the calculator, I'm going to find the square root symbol. So it's going to be in a different location depending on what calculator you have. For me, mine is actually under the second button, so I'm going to have to press second. And then mine goes along with the one that says x squared, but has the square root symbol right above that. So if I press that, so I don't know if y'all can see that, but it looks like that. So square root of 8, close parenthesis, and I get 2.82. Okay, so what I want you to do, I'm not going to write that up there because right now we're just practicing using it in the calculator. So if I take the square root of 8, then it gives me a decimal. So I want you to practice the practice problem, for example, 4 on your own. You don't have to write it down, just simply put it in your calculator. You're taking the square root of 17. So I'm going to do that on my calculator instead of the board. So I press the second. All right, so what you should have gotten is 4.123. Square root symbol, the number 17, close the parenthesis, equals, and you get your answer. All right. Okay, so a little information before we do example 5. If a variable appears in the radicand of a radical expression, it represents positive numbers only. With variables, divide the exponent of the variable by the radical's power. So what we're looking at now is variables, right? Before this, we were all dealing with numbers. So what does it mean when you have a radical and a variable to a certain power? You take the power's exponent under the radical and divide it by the number of that radical on the outside. So we're going to take a look at what that means in our example problems. Okay, we're going to do the first 3 and then we'll do letter D. Okay, so the rule for exponents on a variable under a radical sign. You take the exponent and you divide it by the radical. If there's nothing there, that means it's 2. So the cubic root of 8x to the 8th is 8 divided by 2, which is x to the 4th. On this one, I have coefficients and variables, so start with your coefficient. 64, the cubic root is 4. 4 times 4 times 4. So I know I'm going to have 4 in my final answer. For y to the 12th, 12 divided by 3 gives me y to the 4th. Okay? All right, letter C. I have the square root of x to the 10th over 25. So numerator and denominator treated separately. On my numerator, x to the 10th, I'm taking the square root. So 10 divided by 2 gives me x to the 5th. 25 on the bottom, the square root of 25 is 5. All right, now let's do letter D. Okay, start with your with your coefficient. So this negative sign might be here, but it doesn't affect my variables. It only affects the coefficient. So this is an odd number, which means I can have a negative number under the radical. So the cubic root of negative 64 is going to be negative 4. Now to my variables, I'm focusing on the exponent. 3 divided by 3 gives me 1m. N to the 15th power, 15 divided by 3 is 5, so n to the 5th power. All right, I'm going to erase this to have room for our example problem, our practice problems. So I want you to go ahead and try example 5, letters D, E, and F. Oh, this is to the third. All right, on the first one, square root of 49 is 7. 2 divided by 2 is 1. Z to the fourth, 4 divided by 2 is z squared. 36, the square root is 6. The cubic root of -8 is -2 times -2 times -2. A to the 6, 6 divided by 3 is 2, so a squared. 12 divided by 3 is 4, so b to the fourth. All right, so that is it for 8.1, but I'm going to go ahead and move on to 8.2. So go ahead and switch PowerPoint slides, pull up your 8.2 and follow along. So the goals for 8.2 is to use the product rule to simplify square roots, use the quotient rule to simplify roots, simplify radicals containing variables, and simplify higher roots. Example 1. Simplifying radicals using the product rules allows you to simplify part of the number within the radical while leaving behind what cannot be solved. So the problem with these that makes them different is that they're not going to come out evenly. So what we're going to have to do in all of these problems is we're going to have to factor out and figure out, okay, what underneath that radical can I pull out? And what underneath that radical is going to have to stay behind. All right, so going through the factors of 40, I know that the same number twice cannot equal 40. But what I do know is that I have 4 and I have 10. So 4 times 10. So in this, 4 is a perfect square. 2 times 2. 10 is 2 times 5. So I can't take a perfect square of that. So what we're going to do here is I'm going to actually take the square root of 4, but because 10 doesn't come out evenly, it's going to have to stay behind. So the square root of 4 is 2. So I'm going to write 2. Then I'm going to draw my radical sign. What's left behind? 10. Because it's not a perfect square. There's nothing left in there. 2 and 5 can't go any further. All right, letter B. So let's break it down. 2 times 9. Oh, 9's a perfect square. So what does that mean? That means that I can take the square root of 9, but 2 has to stay behind. So the square root of 9 is 3. So I'm going to pull that out of the radical. What's left behind? 2. All right, on this one, 7 times 100. Oh, looky there. 100 is a perfect square. So what's that mean? We can take the square root of 100, but 7 has to remain. So the square root of 100 is 10. So 10 goes on the outside of the radical. What's left behind that I can't square root? 7. All right, square root of 15. That's 3 times 5. There's nothing there. Those are prime numbers. I can't go any further. So guess what? That's the final answer. The square root of 15 is the square root of 15. Okay, so your practice problems are A and C. Go ahead and give that a try. And we're on page 527. Or actually, I take that back. For the practice, yeah, that's right. Your practice problems are on 527. A and C. All right, so on the first one, I broke it down into 4 times 6. 4 is a perfect square. So I know I can pull the square root of 4 out, which would be 2. Square root of 4 is 2. And then I have 6, but 6 can't be you can't take square root of 6. So that's left behind. Now on this one, I broke 42 into 6 times 7. 6 breaks into 2 times 3. I don't have 2 of the same number on any of these, which means that the entire number has to stay behind. So the square root of 42 is the square root of 42. All right, this time we are okay, so we're expanding on what we just did, but the difference is now we have a number on the outside of the radical symbol and a number on the inside. So what do you do when you have a number on the outside and a number on the inside? Well, you want to make sure that everything on the inside is simplified as far as possible. So what happens if you end up having something under the radical sign that can come out and you already have a number on the outside? So that's what this is going to focus on. So we have 7 square root of 75. Okay, so let's look at this. If I break this down, I have 5 times, actually, you know what? Let's do 3. Let's do 3 times 25. So if I have 3 times 25, what I just realized is, oh look, 25 is a perfect square. So I can take the square root of 25, which means I need to pull 5 out of the radical. So I already have a 7 on the outside. So what does that mean? Anytime you pull a number out from the radical and put it on the outside and there's already a number there, you have to multiply it. So what we're going to do is we're going to multiply the square root of 25, which is 5, times the number that's already there. So this goes away underneath because we just took it from under the radical to now on the outside. And now we have to multiply it by the number that's already there. So 5 times 7 is 35. What's left behind? This 3. So square root of 3. All right, you try it on your own. There's a practice problem for example 2 on page 528. All right, so I broke 40 into 4 times 10. 4 is a perfect square, so if I take the square root of 4, I get 2. So 2 times 5 gives me 10. What's left behind when the 4 goes away? 10. All right, example 3, refer to the quotient rule on page 528. So go ahead and look there. It's in that lavender box. It says if the square root of A and the square root of B are both real numbers, so that means that it's not like a square root of -2, because that's not possible. As long as they're real and B is not 0, then the square root of A over B is the same thing as the square root of A over the square root of B. So you can actually take a fraction in the radical and turn it into a radical over a radical. So that's what we're going to do on this. And you can solve it separately. All right, so I'm actually just going to do these one at a time. All right, square root of 16 over 81. I can actually turn that into the square root of 16 over the square root of 81. And by doing that, then the square root of 16 is 4. The square root of 81 is 9. Okay? All right, so if I do that same rule, break it into top and bottom, square root of 2 over the square root of 25. See, on this one, notice that I can't take the square root of 2, but I can take the square root of 25. So it helps with us separating them from each other. So what that shows me is I still have the square root of 2 left, but on the bottom, I can take the perfect square of 25. It's 5. All right, so if we break this one up, we have the square root of 45 over the square root of 49. So on top, I can't just take the square root of 45, so I'm going to have to break that up. I know that 45 is 9 times 5. 9 just happens to be a perfect square. So that means I'm going to take the square root of 9. So what's the square root of 9? 3. So 3, what's left behind? That 5. So I have 3 square root of 5. On the bottom, what is the square root of 49? Well, I know that 7 times 7 equals 49, so that one's going to come out evenly. Okay, now you try the practice problems A and C on your own. We're on the top of page 529. All right, on the first one, if I break the square root of 5 over 49 into square root of 5 over the square root of 49, I notice the square root of 5 can't go any further, but square root of 49 becomes 7. On the next problem, square root of 18 over 25, I broke it into top and bottom. 18, I can't take the perfect square of, so I broke it into 2 times 9. But 9, I can take the perfect square of. So 9 becomes, the square root of 9 is 3, so 3 is now on the outside, what's left behind? The 2. On the bottom, square root of 25 is a perfect square, so I can take that, which is positive 5. Okay, simplifying radicals containing variables also use the product rule. So what we're going to be doing here is simplifying, assuming that all variables represent positive numbers. So we're doing what we just did, but now we have variables. Okay, so the difference here, now that we're throwing variables into the play of not coming out evenly, the difference is that notice that I can't do 11 divided by 2. I get a decimal. You can't have a decimal exponent. So how do you do this? Well, what it's going to involve if you have a square, if you have this 2, remember that the exponent of a variable is based, when it's multiplied by something, is based on adding. It's based on addition. So what I'm going to do is I'm going to change this exponent into something that I can actually use to take the square root of. So if you remember with the coefficients, we were breaking them into factors, like 2 times 9 for 18. And I noticed, oh, 9 I can take this perfect square of. So what times what can I turn this into so that it's still the same value, but I can actually remove it? So I need an even number as my exponent. So how do I do that? I'm going to change it into a factor of x to the first times x to the 10th. So if I add 1 plus 10, I still get 11. But here's the thing. Now I can get rid of x to the 10th because 10 can divide by 2. So 10 divided by 2 is 5. So that means I'm going to have an x to the 5th on the outside of my square root symbol. What didn't go to the outside? This x. So x remains behind. Okay, so always start with your coefficients. 18. I can't take the perfect square of 18, but 18 is 2 times 9. I can take the perfect square of 9. So the square root of 9 is 3. So 3 is on the outside. Now, before I put anything on the underside of the hat, well, actually, I guess you could go ahead and do that because coefficients are always going to come first. No, I take that back because now we're not going to have space to write what's fully on the outside. Okay, so before you write what's still gonna be under the hat, take a look at your variable. So I have x to the 4th. Can I do 4 divided by 2? Yes, I can. So 4 divided by 2 is 2, so that means I'm going to have an x squared. So this actually went away completely. This 9 went away. What's left? The 2. So square root of 2. All right. Next one, notice we do have our fractions going on. So you can use that dividing the numerator from the denominator if it helps. And so we're actually going to go ahead and do that. So I'm going to change this into the square root of 7y to the 7th over the square root of 25. So on this one, obviously I can't take the square root of 7, so that's not going to go anywhere. For y to the 7th, I'm going to break this into factors. I need it to divide by 2. So if I do y times y to the 6th, 1 plus 6 still equals 7, but I can take the square root of y to the 6th because it's divisible by 2. So 6 divided by 2 is 3. So what that gives me is y to the 3rd. I already said that this 7 can't go anywhere, so 7. What do I have left of the y's? I have a y left underneath. On the bottom, square root of 25 is 5. Okay? All right, so you go ahead and try letters B and D on your own. This is example 4, page 529. Okay, so in the first one, I broke 12 up because I can't take the square root of that. So 3 times 4. 4 is a perfect square. So the square root of 4 is 2. 8 to the 4th, 4 divided by 2 is 2. So those went away. And then what's left behind, the 3 never got used up. So the 3 is still underneath the radical. Letter D. So with this, then I noticed that 11 can't go anywhere. It's prime. It's going to stay. Y to the 9th, though, can be broken up. So I broke it into y times y to the 8th. Y to the 8th is a perfect square. So 8 divided by 2 becomes y to the 4th. What's left behind on top? The 11 is still there. And I still have a leftover y that was not able to be used. On the bottom, the square root of 49 is a perfect square. So 7. All right, simplifying higher roots using the product rule and the quotient rule for radicals is expressed on page 529. That is in the lavender box. So you can see how if you have two numbers being multiplied by itself underneath the same radical sign, you can actually split them up into two different radicals. So it's sort of like what we just did with division. The other cool thing about that is you can actually take them separate and combine them too under the same radical hat. The main thing though is that not the exponent, but the radical number, like square root, cube root, fourth root, that does have to be identical. Okay, if it's like the square root of 3 and the cubic root of 3, then you can't do that. You can't combine them. And then of course it shows you the quotient rule again, that it showed us earlier. It's showing once again that whatever the power is, it has to match on both the top and the bottom. Okay, so let's go ahead and take a look at these. So cubic root of 40. This time I'm looking for a cubic root of something. So what I'm going to do is think through my multiples of 40. Is there something that has a cube root? So I'm going to go and put 5 times 8. 8 is a cubic root. 2 times 2 times 2. So that means I can pull a 2 out. Make sure that the 3 is in my radical. What's left behind? The 5. All right, let's break this up. So I have 5 times 10. I have 2 times 5. Well, make sure that is a 3, yep. So my factors of 50 is 5 times 2 times 5. I have to have 3 of the same number to pull anything out. So the cubic root of 50 is the cubic root of 50. I can't simplify any further. All right, so I'm going to go ahead and change this up a little bit. I'm going to break it up into top and bottom, because one thing I do know is at the bottom, I could take the cubic root of 8. So on the bottom, I know I'm going to have 2. Now for the top, 81. I know that 81 is, let's see, let me just go ahead and do this. I know that 81 is 9 times 9, and that's 3 times 3, that's, actually I should do it this way, 3 times 3. All right, so what I'm looking for is 3 of the same number. If I take this, the 3 of the 4 3s, I can actually pull that out. So I'm going to pull out, I have 3 times 3 times 3, so I'm going to pull out a 3. So that gives me 3 on the outside. What's left behind? 1 3. What I have on the bottom? 2. So that would be my final answer. So some of this really does involve just going through your factors. That's why we practiced it at the beginning of this course. Because you have to look for, when we start getting into bigger roots than just 2, you're looking for multiples of the same number, not just 2 of the same number. Okay, so you're gonna do practice problems A and D on your own. I'm gonna go ahead and erase this so I have space to do it. So you go ahead and start your problems, and then I will have the answers up here in just a second. Oh, whoops. I didn't mean to erase that. All right, you're on page 530 if you haven't done it yet. A and D. Okay, on letter A, I had to break it up. I broke it into 3 times 8, and I was like, oh, 8's a cubic root. So the cubic root of 8 is 2. What's left behind? The 3. On this one, I broke it into top and bottom, square root of 15 over square root, oh, sorry, not square root, cubic root of 15 over cubic root of 64. So 15 is 3 times 5. So I can't do anything with that. So that stays the same. On the bottom though, cubic root of 64, I know I can take the cubic root of that. It's 4 times 4 times 4, so that's left on the bottom. Oh, wait, did I write that correctly? Yeah, I did. Okay, I was looking at something different. All right, so good news if you've been able to hang in with me. This is the last problem of this video. The last problem is section 8.2. And the greatest thing about that after this is that we only have one more video left of the semester. It will cover 8.3 and 8.4. And, well, one of them is longer than the other. I might break it up. I haven't decided yet. But we're almost there. Basically, we got 2 sections left of the semester. So the homework assignment for this is already on Canvas. And homework for chapter 8 is all going to be due on, I think I have it due on May 5th. So you don't have a lot of time for this chapter, but it is really short. So just go back and rewatch the video if you need to. Try some test practice problems. Since we are so close to the end of the semester, I'm not going to worry about trying to do a review video for this chapter. But anyways, this is our last problem of this video, and we're almost there. So just hang in there. We're almost to the end. Okay, so we're doing extra practice, sort of building on everything we've been doing. The difference on these is that we're just playing with bigger numbers. So we are doing to the 4th root instead of to the cubic root. Okay, on this first one, so I'm just going to break this up into, let's see, 2 times 16. Okay, well, actually by doing that, I just realized 16 just so happens to be a fourth root. I can make a fourth root from 16. 16 is 4 times 4. 4 times 4 is 2 times 2 each. So the fourth root of 16 is 2. So that means I can pull it out. What's left behind? I need to make sure I have my little 4 there. What's left behind? This other 2. Okay, so 2, fourth root of 2 is the answer. On this one, we have the fourth root of 7 over 256. So the first thing I'm going to start by is just changing this to the fourth root of 7 over the fourth root of 256. Something I know is I can't do anything to 7. It's prime. It's going to stay under the radical. But with 256, we actually did the fourth root of 256 earlier in this section, so I just happen to know that the fourth root of 256 is 4. Yeah, it's 4. So since I know this simplifies to 4, my final answer here would be the fourth root of 7 over 4. All right, on the fifth root of 160, we're just going to start breaking stuff up. Okay, I know that it equals 16 times 10. 10 is 2 times 5. 16 is 4 and 4, which is 2 and 2. And looky there. We have 1, 2, 3, 4, 5 2s. So what does that mean? If I have 5 of the same number, I can pull it out. So I'm going to pull out a 2. I have the fifth root radical symbol. What ended up being left behind? This lonely little 5. And that's your final answer. Okay, so go ahead and do practice problems B and C on your own, and we're done with this video. We're on page 530. All right, so on letter B, I broke it up into top and bottom. I can't do anything to 5, so that stays the same, fourth root of 5. On the bottom, the fourth root of 81 is 3. On this one, 96, I'm trying to find a fifth root. So I broke 96 up and I just kept dividing it by 2, and then I realized when I got to the end, hey, there's 5 2s. So that means I was able to pull out the 2, so that's how I get 2. Fifth root. And then what's left behind? At the very bottom, I had the factor 6, which is 2 times 3. So the 2, of course, ended up popping out. The 3 is left behind, so that's where I get 3 under the hat. All right, that concludes this video. If you have any questions, please message me, let me know. I know that this chapter is going to be moving pretty quickly, but that does not mean that I'm not willing to help you. So just let me know, and I will reach out to you. And then just try to go ahead and take a look at the homework assignment. It is due next week. All right, bye.